I'm Anil Kumar, and in this video we will understand how to sketch a reciprocal of a function given to us. Now in this particular video I've taken purposely reciprocal of a linear scatter plot. Now we have set of points, these are not connected, right? So the reciprocal should not be connected. Think like this, that we are given a table of values in which we are written x and y values, and I have just plotted them on a graph. Think like this, and you need to sketch reciprocal of that function, correct? So the question here is sketch reciprocal of the given function and write its domain and range. That is the question. Now in this case we are given a graph and some points on the graph. It is a good practice to write down the coordinates of these points. Let's begin by writing the coordinates of these points one by one from left to right. So we have -4 and the y value is 6. And then we have -3 and y value is 5. So I've taken very easy values to work with. So they are actually decreasing like this, okay, 3. And then when it is 0, let us check. It is 2. So we are on the right path, correct. So as we move forward, 1. So 1 will give me the value is 1. And at 2, the value is 0. Good. So that is the x-intercept. And at 3, we have -1. And at 4, we have -2. Likewise, correct? So likewise, these values are given to us. Okay. Now we need to sketch the reciprocal of the function. So what we can do here is we can write down reciprocal and then figure out how to place them on the table. Now when we are saying reciprocal of a function, x values remain same. Do you understand? The y value is the reciprocal value. So at -4, reciprocal of 6 is 1/6. So that becomes the reciprocal value. I hope you understand, appreciate that part, right? So at -3, the reciprocal will be 1/5. At -2, it will be 1/4. At -1, it should be 1/3. At 0, it is 1/2. At 1, it is 1, right? Reciprocal of 1 is 1. We call this as invariant point. Now at 2, it is 1/0. 1/0 is not defined, correct? So that does not exist. So let me write does not exist, okay? Now at 3, it be negative. So reciprocal is going to be negative. -1, reciprocal is -1. And for 4, -2 is negative. Reciprocal will be negative. But 2 reciprocal is half, right? So like that, we'll get these reciprocal values. Well, I should have taken one value as half also, just to show you that it becomes twice, right? So anyway, we haven't taken it here. Let me introduce one value, okay? So what I'm saying is that there is a point introduced here, and this point is at 1.5, I have 0.5. So I'm introducing a point here and saying at 1.5, my value is half. So at 1.5, let me write 1.5, reciprocal of half will be 2, okay? So we'll put it there, right? We'll put it there. So that'd be a good point to consider. Even this point is good. It will help us to make a better graph also. So we'll introduce one more point, which is 2.5. So we'll say 2.5 is -half. So at 2.5, the value will be -2. Okay, great. So we have table values. We have a graph, which is a scatter plot, and we need to sketch reciprocal of this function given to us. Now, whenever you are given to sketch reciprocal of a function, you should start with, I should say, x-intercept. Now, as you can see, that does not exist, right? This is the point. So if the function is 0, 1/0 is not defined, so we have a vertical asymptote here. So we'll draw a vertical asymptote. So this is the first thing which you should normally do when you're sketching reciprocal of the function. Second important thing which I think you should look into is invariant points. So second thing is, so first we are looking for vertical asymptote. Second point, we look for invariant points. Invariant means which are common for both. So 1 over 1 is 1, so that is one of them. The other one is minus 1, so this is the other ones, right? So these are common to both the graphs. So my point or reciprocal function will be exactly at the same place, correct? Invariant points. Now we should know that reciprocal of positive numbers will be positive, which we can see here, right? Reciprocal. But as the value is more than 1, they become lower and lower. For 2, reciprocal is half. So for 2, this point will be plotted here. Now this is 3, so this is 1/3, correct? So less than half, like this. And then 4, much closer, 5. So it will be 1 over 5, 6, 1 over 6. As these values are going higher, our values are coming lower and lower, and they are approaching 0, right? So the end behavior is kind of, as we are approaching minus infinity for x, the y value is approaching 0. Okay. On this side, we have a value half, and reciprocal of half is 2, so we get a point here. We did not take any points much closer, but you can see these points actually increase, and as we approach 0, they are approaching infinity. But anyway, the reciprocal function graph will have these points for the ones which we have. Now, for minus half, reciprocal of minus half is going to be minus 2. So we'll have a point here. Then we have an invariant point, and this is 2. 2 reciprocal is half. 3, 1/3. And then minus 4, minus 1/4. So those are the points on the reciprocal function. Do you understand? So these are the points. And the vertical asymptote. So that represents our data for reciprocal function. Now the question is, what is the domain and what is the range for the reciprocal function? So the domain is the same as the domain of the function, correct? Except for one point, and that is where we have vertical asymptote. Do you understand? This part is not there in the domain of our reciprocal function, correct? All other points will be included, correct? So we can write domain as, so we say domain of reciprocal function is equal to these points, which are minus 4, minus 3, minus 2, minus 1, 0. Also 1. We introduced 1.5, okay, let me write 1.5, but not 2, because at 2 we have a vertical asymptote, right? We have 3, we have 4, and I did not write the values of 5 and 6, but they are in our domain, right? So 5 and 6. So critical thing which I want to tell you here is that the domain of reciprocal function will not have a point which corresponded to 0 in the function itself. That means the x-intercepts, correct? That is very important, right? Now let's look into the range, right? So what is the range for us? So we can write range now, which is the set of y values as equal to all these fractions which we have, right? So 1 over 6, 1 over 5, 1 over 4, 1 over 3, 1 over 2, 1 itself, and then we have minus 1, minus half. We also have minus 1 over 3, minus 1 over 4, correct? So up to minus 1 over 4. So these are all the points in our range, and of course we do not have 0 in our range, okay? So 0 will never be in our range for reciprocal of such a graph. I hope that helps you to understand the concept. Remember not to connect these points, as we are only talking about some fixed points, right? So that is how you should look into the function itself. I hope that helps. Thank you and all the best.